This is the best you're gonna get. This is the best part of the whole presentation of those grapes. So just to officially and formally tell you who your presenters are, because you probably don't even know our last name. So I'm Bobby Smith, technically Dr. Smith, but that doesn't matter.
And I'm Alan Bella.
And so we had to coordinate because Alan joined the class a little bit later, and so I kind of started the experiment and then it went on from there. So we had pretty big expectations, and the reality was a little bit of a disappointment, but in looking at our grape seeds, there were some germination treatments of Vitis vinifera, and that is the European grape vine, and there's like 2 other species of grapes. And the original idea came from Dr. D. He gave me a research experiment, but it was from Kurdistan, and the way they got their grape seeds was that they went to the local market in August and they were studying Rash Mary, which is Rash in Kurd means dark, and it's actually considered a national treasure. And there was a gentleman, a farmer in Kurdistan, that said, if you can find a better grape, I'll give you $10,000. So the research that they did was conducted in the COVID period, right after the conflict. So science goes on regardless of situation. So their experiment involved this landrace grape it's used for wine and for table grapes, and it's very large and very dark, and it only has 4 seeds each, and so there was a lot of work on their part to get those seeds out of those grapes. So the experiment, just to wrap it up, was they stratified their seeds for 30, 60, and 90 days, and they treated them with gibberellic acid or GA3, and they found, the end result was that the longer the stratification with that dosage of acid, it awoke the seeds both physiologically and physically, because seeds are notorious, or grape seeds are notorious for not wanting to come out of dormancy. So that's how we started, and before you was the proposal. And so as you can see, it was a little grandiose, but before we get to that, this was the tag that came with our seeds, and the cultivar is not mentioned. It's kind of like a general idea of what these seeds are, and this tag is based on the AOSA, which is the Bible for seeds. And they said at the time that they cut them open, kind of like how we did for the TZ test, and they said that 91% could germinate, but that was over 5 years ago. So those were pretty old seeds, and they did not come in a special seal. It came in a plastic bag. And all those codes there, those are kind of important because it tells you what they had to do in order to put that tag out the way it is. So their suggestion is soak seeds in water, let it stand for 24 hours, stratify them to 60 to 90 days, and plant them, according to the AOSA, a quarter depth. But even if you did that, that is not what happened on our experiment. But anyway, so again, this is there's a book, and you would look it up. So it tells you the medium that they planted in it, and the temperature. It's a diurnal temperature. So ideally, daytime would be 86 degrees Fahrenheit, and nighttime would be 68. And so just kind of keep that rolling around in your mind when I go through the other slides, because it kind of comes up later. So our thesis was really aggressive. It was that by clipping the distal end of the seed, which I'll show you in a minute, and then treating it with a signaling compound, hydrogen peroxide, which is 3%, which is exactly the stuff you can buy at the store. And although it's like 5 molar, that these seeds would germinate within a 60-day window. But there were a few complications, one of which is because I froze the seeds. But we used those seeds, and so the distal end is the far side, and it's the more rounder part of the seed that got clipped, and this was like the treatment number 3. And so you can't really see it so much with this picture, but the seed on your left is white, and that means the embryo is good and not necrotic. And many of the seeds, and the seed on the right is brown, and it was not viable. So there were a lot of seeds. So when I was clipping, I was throwing at least half of them away because I could not get to a white inner seed. So that was kind of an interesting thing that I didn't know the significance of when I was trying to clip the seeds. So why did we do the experiment other than we had to? So when you look at this chart, the hypothesis is that clipping along with stratification, those two things, not stratification, clipping and signaling with hydrogen peroxide would activate the seed at least greater than 45%. But that's not exactly what happened. But there's a lot of references to the right. A lot of the references, however, were the different species. So these percentages aren't exactly what would be expected with this specific cultivar, which we don't even know what it is, but that's something to keep in the back of your mind. So commercially, most productive grape seed producers or grapevine producers, they expect anywhere from 30 to 50%, not down there at 90%. So to go over the treatment groups, of course, we had a control, which was just placing a seed with no treatments at all in the medium. And then T1 was just soaking it, but instead of 48 hours like the tag said, or instead of 24 hours like the tag said, we did it for 48. And that was mostly because of the way our labs were working Monday to Wednesday. And then our T2 was just the gibberellic acid of 1,500 parts per minute. Now, that's a little bit controversial. Some say that it makes a toxic dose. Others say like 1,000 is safer. But Connor did one in auger at 5,000 ppm and got relatively decent results in his experiment with stratification. So, and then T4 was refrigerator stratification in that refrigerator. And then because I made a oops at home, I froze the seeds for 12 days at 2 degrees Fahrenheit and took a picture of it. And then it got caught later, so they had they had stratification for 48 days and then frozen for 12. And then the T5 had the hormone added to the stratification to break both the physiologic and the physical dormancy of the grape seed. And then TA5 was the same thing, again, a frozen seed with refrigeration but with hormone. So most of our results garnered no germination at all. The control didn't do it, and as you see, nothing did it except for the seeds that were soaked in water and the seeds that were frozen without the hormone. So one idea with the freezing is that it created microfractures within the seed, not enough to kill the embryo, but enough to let it break out. So moving on to, this was a variable we could not control because it's in the greenhouse, and the greenhouse that I know of. So we started on April Fool's, go figure, right? And it was like perfect. That's exactly what you wanted for temperature. And then we kind of had a little bit of a cold spell, and so it dropped. And that affected the germination as well, because ideally you want it between 86 and 68 degrees Fahrenheit, day and night, respectively. And this shows, again, the results and how the emergence came about. And so during the experiment, we literally planted 315 seeds because statistically we didn't want like one seed that didn't do it to throw our statistics way off. And our statistics included an ANOVA test for the means, and
with multiple range tests.
so, right, and then as a comparative, we used the Duncan mixed range test in conjunction with the ANOVA test. But that's Alan's lane, and I'm not going to cross into it. So it's your turn now.
Yay. So with the only two treatments groups that emerged was T1 and T4 up here. So we love our graphs. so this is what we did. So then I had to do the two tests, which was ANOVA, which was the analysis of variance. And what this is, it compares the treatment groups and asks, did the treatment type affect emergence? ANOVA, it doesn't tell us which treatment was best. It only tells us whether at least one treatment was different from the others. And so with our result, it was significant because our p-value was less than 5%. With less than 5%, that's just a cutoff of the statistical significance. And so the next test was the DMRT, which is the Duncan's multiple range test. After the ANOVA, that shows the differences that existed, whereas the DMRT showed the treatments were different overall. So they were placed into letter grades, which was A, B, and C. So with alpha, the best one was the highest emergence, which was treatment 4 alpha. B tier was the treatment 1, which only had 3 plants that merged, and the rest that didn't merge was in the C tier. And so we did have a lot of complications with our grapes. And so with the clipping, which what Bobby did the most, we didn't have a lot of seed viability with the endosperm because it was anti-necrotic brown on the inside. So that could cause a lot of the issues with not growing. And then we did have some fungal disease when we did soak some of the seeds in the water, leaving it in the freezer. So we did have to use a filtered water using the 50-50 dilution of bleach and the hydrogen peroxide for the clip seeds. And we're assuming with the clip seeds, since they're necrotic, they're 5 years old, with other issues, that once it was exposed to the embryo, it's probably stressed out completely to where it rot in the inside or into the and then also with our research, we did cut it down a lot because of our semester. So instead of at least being at 60 days or even at optimum levels of 90 days of stratification, we cut it down to 47 to 48 days. And so that probably delayed it as well. It probably killed the seed as well. And then with our future research designs, we incorporate a backward planning of the experimental timeline to accommodate the full stratification requirements, which with our only great emergence from treatment 4 alpha, that just shows that the stratification process was much more preferred for the grape seeds rather than the other treatment groups that we did. And so with some of the treatment groups that was exposed with the hormone, the GA3, it was probably due to the high concentration of it to where it probably inhibited the growth or made it toxic to the cultivar. And then again about the shortening or experiments to 47 days instead of the optimum result 90 days, that probably caused a complication. And then the combination of refrigeration and freezing with that T4 alpha, that was the only successful one. And even on day 2, that's where it showed significant emergence. And here's our references. That's it.
So if you guys were to do the experiment again, would you focus more on the stratification and the freezing since you got better results with that? Or would you continue to the GA application?
Well, initially I would focus on the viability of the seed because that source seed, it was actually a test question I missed. We both missed it. Where you have that source seed, I was kind of doubtful of it, but you know, I would probably choose a USDA seed, and I would probably, and you can correct me, I would probably try that rapid induction, which was the hypothesis, is a little aggressive. It was a little high in expectation. So I guess I would, honestly, I would repeat the same thing with a different cultivar, knowing more of the cultivar's nature. Because there's southern grapes and northern grapes, and they respond, grape seeds are really heterozygous a lot. And so even within a batch of seeds, you can have some that have a thinner seed skin, the testa, than others. So to really eliminate like the complications and also like the stratification, seeing all that mold on our stratification seeds, that was a little upsetting. So treating for fungal prior to, now we treated for fungal in between, because they can also rot in soil. So we did take the ones that were stratified, clean them off amazingly, cast out the floaters, and then treat it with 50-50 bleach solution for 48 hours, I believe. And so I would, because there were so many complications, I would almost replicate it the same way, but with a different seed source, and treat for that antifungal, and then make sure that the temperature was varying, like perfectly, because we weren't at all within the conditions that would be optimal for the temperature range for at least 10 of the 21 days we had. So.
And also test for that seed viability, like we did in lab 1. That's something we should have did as well. I think it's a TTC test.
Yes.
That would have helped a lot, but other than that, yeah.
Good question, thank you.
Kind of piggybacking off of Michael's question, if you had like the exact same time frame that you were dealing with, and maybe a different cultivar that was a little bit more heat tolerant, still, would you think that instead of dealing with refrigeration at all, that maybe you would test different like amounts of freezing, like 5 days, 10 days, 15 days, because their time was so limited?
Right, that and I was kind of new to the whole idea as well. And then, to add things in, Alan showed up later. So then, which was, I'm grateful for, because it made the experiment nicer to do with a partner. But it was, I actually rewrote, that's a modified proposal because of the freezing. And to answer your question more directly, yes, that would be a follow-on one to see, because we still got only 15% with the frozen, and that it should have been higher. So that would be a great, if you just wanted to see if freezing would break that cycle. But knowing your cultivar is like really important, because there's southern grapes that have adapted to that, and then other ones like the Rash Mary, the one from Kurdistan, they're grown in the mountains, and they're just rainwater is how they're grown. And so, it really depends on your cultivar, and this was not listed on the tag. And I didn't know enough at the time to know that that was gonna be important, and it really is. And so there's like 13 different wine cultivars that we use, but there's over like 2,000 grapevines that we don't know about. So the end of the Rush Mary experiment said we need to know more about our local grapes. And they're actually exported as well. That's like a big thing for them. So, I would definitely be a lot more specific. And I think even all PhDs, they say, make sure your problem is super narrow and specific. And that would be, what the follow-on would be. So in addressing like narrowing down that freezing point and comparing, yeah, that would be a great experiment to do. Come on, do the Blue Falcon. Make it so we can't answer the question. That's an Air Force term, like you get a sharpshooter in there that knows more than you, and they.
I have some suggestions to improve the presentation. That is what I was telling. You could ask from there's no introduction on your slide, so I would suggest to improve your slide by talking about why the study was needed. We know that what they did is similar to what we did in lab 2 on golden entry, which is known to have theoretical dormancy. So we're just going to, the same thing that it will be. So try to improve your introduction, talking about why grape is known to have a theoretical dormancy, and then you are testing different methods to improve it. We don't need to know about Kurdistan or whatever you what happened. So that's what I will help you is the assignment, and you're gonna improve your introduction, talking about the rationale of the study. Also, I did not see the objective of the study. The hypothesis need to be reformulated. Usually, hypothesis should be derived from the treatment that you test. You're talking about, I did not see anything about GA and all that. So reformulate the hypothesis and put the objective. And overall, it's a failed experiment because of the quality of the seed. So I don't know how you come up with a NOVA study. So I won't. Those are NOVA. I will not.
The magic of publication.
Yeah, don't pretend they're NOVA. It's a field experiment, given all the situation. I don't blame you for that because of the seed quality and all that. But make some correction, introduction, objective, and all that.
Okay.
I don't think all those are NOVA results that you put them make any sense.
All right. Well,
Can I ask you, Keith?
as a suggestion, please framework what slides we need, because we were pretty much operating like never done it before, didn't know what the framework should be. So if you could have done an outline as to far as kind of what we needed to frame our presentation in, that would have been helpful.
You came up with proposal, which actually aligned your proposal before.
Right.
Why you didn't follow the proposal in your presentation?
Your
We
proposal.
passed it out.
No, we want to see the presentation have to show the rationale and all that.
Okay. Well,
So do some correction on that.
sure.
And also, how did you get the weather data that you showed me?
Well, unfortunately, we didn't look at the anerometer that was here, but I mean, I looked it up from the local place of commerce.
No,
and
then-
that's all I had.
No,
I know there's
because
microclimates
It was
here.
different. Outside was different from greenhouse, so don't show those. They are not great. The weather-
Is our greenhouse heated at night though? It's not.
Yes.
Is it?
Yes.
Okay.
If you really need to get, Dr. How can give you the weather out there? I don't.
No. No, our greenhouse is scheduled about 65.
Okay,
Okay.
yeah, we can, Dr. How you can ask question. We have,
Doesn't matter because the high wasn't.
Okay, it won't take long.
yeah, one question, so we can move on to the second.
Okay, question I have, you were mentioning northern and southern grapes. What do you mean?
The different varietals, like the
Such
north.
as?
Okay. He's gonna stick it to me.
I'm just curious, you had vinifera.
So the Rush Mary grape in general, like I'll just go to that, it's actually a southern grape that adapted to the northern Kurdistan.
What is raspberry?
It's the cultivar of the initial research project that we tailored ours after initially.
Okay.
The proposal.
Is it related to vinifera?
Yes, it is. Yes, it's a cultivar of it.
Okay. Did you find any other work on vinifera seed germination?
I did, and they were all listed like Connor. He increased his ppm to 5,000. He grew his in auger, and it was the rotundium. The round leafed. It's a different species of grape, and so the reference that I was referring to, his research was on a different species of grape, the American grape, like a muscadine, and so he
Most
was,
of them are getting into a very completely different species.
we're right, but that was
Very
his research was on that, and he grew it in auger with the 5,000 ppm, and that percentage was based on that research. So, and then Bolt did a lot of just that species, the vinifera vitis vinifera. And that's how I was getting the percentage for the water soaking and the different, he also did the one with hydrogen peroxide, but it was,
Okay, so what you mean by northern versus southern is
it's like a climate type adaptation of this different species.
okay, what would be northern?
We'll just say grapes grown like viticulture grapes grown in New York that have to endure their winters, and the viticulture grapes grown in California that don't have to endure that cold of weather. That's more of a Mediterranean weather and fog and different humidity versus the viticulture grapes grown in New York State.
Just curious, do you know where vinifera grapes are native to?
Europe, or European grape
They're
variety.
almost all Mediterranean,
Right.
and so they have almost no cold hardness whatsoever, so that'd be,
Well, those Rashmeri are from India, and they are that, and they somehow adapted. I mean, it's.
Okay, let's continue to talk. Let's do one more. Yeah, you need, like, those are the things that we need to see on the introduction.
Okay.
Where grape are native, all that. I will, like I said, I will open the assignment, and then you will incorporate all those suggestions.
Okay.
Okay, let's do.
After all, I like your presentation, guys.
Let's do
It's good.
one more.